Okay, today we're looking at 4.6 quick graphs using slope-intercept form. Our two goals, we're graphing linear equations in slope-intercept form. We'll talk about what that is. And we're graphing and interpreting equations in slope-intercept form that model real-life situations. First thing we have, or a couple of definitions. Slope-intercept form is a linear equation written in the form y equals mx plus b, where m is the slope of the line and b is the y-intercept. We can take that a little bit further, and we could actually identify everything in that equation. Y equals mx plus b. Um, the first two most notable things are what they mentioned to you in the definition, m and b. Uh, that's your slope and your y-intercept. Slope is m, and we've talked about that already. B is the one that's new to us. B is our y-intercept. That is where it crosses through the y-axis. So you have four things. You have four things, including those two. You have a y and you have an x when it's talking about variables. The y is in an ordered pair. It is there's an x and a y. It is the y value in an ordered pair that falls in that equation. The m is the slope. The x, if the y was the y value in the ordered pair, then the x is the x value of the order of that same ordered pair, and then the b is the y-intercept. And the y-intercept is, when you're looking at a graph, we know that this is our y-axis, the one going up and down. If a graph is coming through our axes, this part right here is your y-intercept, because that's where it crosses through the y-axis. The next thing is definition of parallel. Most of us in here are familiar with what parallel means. It means the two lines will never cross each other. This is taking it one step further. It's saying that they're in the same plane. There are another set of lines that will never cross each other that are not parallel, and those are called skew lines, but we won't really talk much about them until you get to a geometry class. What's important about parallel lines as you look at them is their distance apart from each other. Their distance is the same at all parts because they'll never cross each other. The symbol for parallel is just two little parallel lines next to each other. So if this was line A and this was line B, you could say A is parallel to B, written like that. Our first example is slope-intercept form of equation of a line. It says the linear equation y equals mx plus b is written in slope-intercept form. The slope of the line is m, the y-intercept of the line is b. The first example says the linear equation y equals 2x plus 3 has a slope of 2 and a y-intercept of 3. Yeah, all you got to do is label it mx plus b. Simple as that. Mx plus b. Then we have a few examples to go along with number one. Y equals 5 minus 2x. Notice this is in function form, y equals 5 minus 2x, but it's not in slope-intercept form. Whatever's multiplying by x has to be first. So as you're looking at your two terms, one of them is 5, the other one is negative 2x. All you're going to do is reorder those. Just change their order. And we did this. We started doing this last week to where we can get used to slope-intercept form. So y equals 5 minus 2x becomes y equals negative 2x because the minus goes with the 2x. Remember, the sign goes with what's the number behind it. Negative 2x plus 5. Now it is in mx plus b form. So your m is negative 2 and your b is 5. The second one, y equals x minus 2 times 3. In order to look at this one, you separate this fraction here, and we showed this last week as well. Separate this to show something multiplying by x. Now there's a 1 in front of that x. Remember, there's a one coefficient in front of everything that's not showing a coefficient. So we can have that 1 being divided by 3, and that's what we have going on here. 1 being divided by 3 times x, and then the negative 2. So instead of doing the Hart method, we're taking that and we're dividing each of those terms, 1x and negative 2, by 3. So what you're given at that point is you're given a form of mx plus b. And again, you can label it mx plus b. Notice the sign, as would be is here. The sign goes that's in front of the term is what it goes with it. So its b value or its y-intercept is negative 2 over 3. For this one, we have y equals 13. It's y equals, there is no mx value. There's a missing spot here for this mx value because it's nothing times x. So its slope will be 0. M is going to be 0 in that case, and b is going to be, or its y-intercept is going to be 13. So it's still mx plus b. In that case, just the mx isn't shown since it's only y equals 13. And then the last one, 2.2x minus 4y equals 0. You need to move everything to the other side of the equation to get y by itself. So you want to move 2.2x on over to the other side. It's positive 2.2x, so you subtract 2.2x. When you do that, it cancels it out. You have to subtract 2.2x on this side. You're left with, and I'm going to move this all the way out the way, but you're left with negative 4.4y equals negative 2.2x, just to go through one step shorter, plus 0. And then get rid of that negative 4.4 times y by dividing by negative 4.4. You divide that side by negative 4.4, you need to divide this side by negative 4.4. And again, we could show that and we could show this, even though it's unnecessary because 0 divided by anything will simply be 0. This will cancel out and leave you with just y. And then a negative divided by a negative is going to be equal to 0.5x. And then again, 0 plus 0 divided by anything will simply be 0. And this is the equation that you have here. 0.5 times x plus 0, where 0.5 is your m. It's not 0.5x. It's what's multiplying by x. So 0.5 is your m, and 0 is your b, or your y-intercept. Here's your first checkpoint. Y equals 4 minus 3x. That's not in mx plus b form. Change your order. So instead of saying 4 minus 3x, we'll change it to y equals negative 3x, because remember, the sign goes with what's the number that's behind the sign, and it's positive 4. Now it's in mx plus b form, so this is m, not negative 3x, but negative 3 is m, and b is 4, and it's positive 4. Number 2 says 2x plus y equals negative 3. Again, we need to get y by itself, so we want to move this positive 2x over. So let's look at that equation here. 2x plus y equals negative 3. It's positive 2x, which means plus 2x. Do the inverse of that and subtract 2x. If you subtract 2x on the left, you need to subtract 2x on the right. Cancel these out. It leaves you with y equals, and again, let's put our x term first, our variable term first. It is a negative 2x and then negative 3. So this is now in slope-intercept form. Y equals something times x, or mx, and it's the negative 2. Don't leave your negative off, plus b. Plus b is the same thing as minus b. So it's going to be a negative 3. So your slope is negative 2, your m is negative 2, and your y-intercept, or your b value, is not positive 3, but it's negative 3. And then the last one on that page, separate from the Hart method, separate it into two separate terms. So y equals 3 over 4x, or just 3 divided by 4, minus 8 divided by 4 would be, we'll show the step, minus 8 divided by 4, which 8 divided by 4 we know is 2. So y equals 3 over 4x minus 2. That is mx plus b form. M is the slope, which is multiplying by x, and b, again, it's plus b. You have to include the sign. It's negative 2. So your slope 3/4, your y-intercept, or your b value, is negative 2. Your next example is graphing using slope and y-intercept. It says write the equation in slope-intercept form. So what we want to do is we want to move this negative 2x over. It's minus 2x. Do the inverse of that, add 2x. It'll cancel it out and leave you with just y on that side. If you add 2x to the left, you need to add 2x to the right. So positive 2x, negative 3. That's slope-intercept form. Y equals 2x minus 3. When you find your slope and your y-intercept, you can label it's mx plus b. The m is usually easy for everybody once they get the hang of it. People forget to put the negative with the b. So m is 2 and b is negative 3. It says plot the point 0, negative 3. Again, not necessarily super necessary to do. And I know it's a little redundant saying that, but just go to y's value. We know this is our y-axis. Go to y's value of negative 3, and that's what you want to plot. So your y-intercept that is your starting, that's your starting point, and your slope, those are your directions. So as you're graphing it, start at the y-intercept. That's this point here, negative 3. So that's where we're going to start, at negative 3 on the y value. Then your slope is 2. Now, all slopes are rise over run. Remember, m is the rise, so up or down over the run, left or right. If it is a positive number, it means it's going up. If it's negative, it's going down. If it's negative on the bottom, it's going to the left. If it's positive, it's going to the right. So from your starting point of negative 3, we have our directions tell us 2. Every number is over 1, and that's important when you're talking about slopes, since you need to do a rise over a run. Positive 2 tells us to go up 2 times. So from our point here, we go up, and I'm going to get a different color. We go up 2 times, 1, 2, and it tells us to go to the right 1 time to that point there, and you plot your 2 points. So what you have when your starting point was negative 3, your slope told you to go up 2 and over 1. You have 2 points that you can graph. And you rise over your run, 2 over 1. Identifying families of parallel lines. Parallel lines have the same slope. That's the important part. And we mentioned that the other day. They have the same slope. The first equation, negative 2x plus y equals 4, you need to get it in a form where you can see the slope. So you need to move negative 2x over. If you it's saying subtract 2x, you need to add 2x. So y equals, if you add it on the left, it'll cancel it out. You have to add it to the right. Positive 2x plus 4. Your second equation, when you move it, when you change it, I should say, let's try to speed this up a little bit. You move your positive x over. What it has is x plus 2y equals 6. You need to move the positive x over. It's plus x, so you need to subtract x. When it goes to the other side, it becomes negative. These will cancel. 2y equals negative x positive 6, or plus 6. Then divide by 2 on both sides. Divide by 2. These will cancel. Y equals negative 1 divided by 2x, and then 6 divided by 2 would be plus 3. Now it is in mx plus b form. This one is also in mx plus b form. Then you need to move the last one into mx plus b form. Move 8x on over to the right side. It's positive 8x, so subtract it. What you're left with is negative 4y equals, it was positive on the left, so it's going to be negative 8x on the right, and it's still positive 5. You don't change that one because that one didn't move across the equal sign. Divide by negative 4, and it'll cancel it out. Divide this one by negative 4 and this one by negative 4. So what you're left with is y equals negative 8 divided by negative 4 is positive 2x, and then a positive divided by a negative would be negative 5 over 4. So what you have here, as you're looking at it, you have mx plus b. The important part with slope is that they have the same slope when you're talking about parallel lines, and line C and line A both have 2 as their slope, so that means they are parallel. And here are your checkpoint problems. We'll check your answers versus what we're showing here. I'm running out of time in 15 minutes. I just want to show you real quick, and we'll talk through these when we get back on Wednesday. And then here are your last ones.